All right, so looking at this data here, I'm going to want to visualize it. So I create a scatter plot. There I can see it. I see a point up here, which, as the cuvette went in, or the computer for some reason took one point up here. So if I, for example, just take if I were to just do a plot of these numbers here, insert a scatter plot on that really quick. And then if I were to take the trend line, I see that the trend line doesn't follow the slope that I actually see the data following. So I want my slope to follow the general trend of that whole line there. Okay, so for this one, I could probably take the whole line because it looks pretty linear. It might be slightly slowing down up here, so usually you just want to take it within the first 40 seconds. But this point right here, this top left corner of these blue boxes, is the LINEST program. It's basically taking a scatter plot and taking the slope of this line. It's just taking the slope of this line, or the data that you have here. And I want to make sure, see I can change the data like this. I want to make sure that the data that it takes, so double click on it so I can get hold of it again. I want to make sure that the data that it takes represents this line here. All right, so if I push enter there, it tells me the slope, 9.84 times 10 to the minus 5. I can double click here and see what those were again. 16 to 44. I can highlight 16 to 44, create myself another scatter plot here, and then right click on that and add a trend line. Let's see, right click on the equation, add trend line equation. So that's 1 times 10 to the minus 4. Format, if I want to get more significant digits, where is it at? Number, format, general, number, decimal points, let's do 6. So 0.009, 0.8 times 10 to the minus 5. This is 9.8 times 10. Oh, that's the same slope. So this one here, if I right click here, add a trend line. Here's another way I can put the equation on the thing there. 8 times 10 to the minus 5. So I've just verified by kind of inspecting that the actual LINEST equation, I'm going to delete this here, don't need all this. I just verified that this LINEST equation here is a good representation of the data. It's following along that trend. If I was concerned, I could make it a little bit bigger. Oh, man. Come on. All right, so that one's good. I can take this here and just drag it over to here. Probably want to make this a little bit bigger so I can see more of the plot. Okay, so again, do the same thing with each one of these, making sure that, you can look at the data and you can see where the trend is leading. There are some bumps in the way there, and one thing we could do is take out those bumps and just try to get the trend, but it's better to just make sure that this value here represents the trend that we're seeing well. So you're just going to go through all of these and verify that all of those values are represented well by this LINEST equation. All right, again, pay attention to points here, pay attention to the bumpiness here. Try to just make sure, you can always right click on any data and just add your own trend line and equation. So you can see here how this line is a little bit higher than these points here. It's because these points are kind of bending it down, so the slope is a little bit faster than it is over here. So the resulting average of all this is a little bit shallower slope. We'd really like to find the slope of this beginning, again, 40, 50 seconds. I could do that here by looking at the data between whatever this one is, about 25 to 45, 50, 45 to 50. That'd probably be a good range for this line S to go through. But there's some higher points and lower points though, so this probably works out too. Okay.